In the annals of space exploration, humanity has always striven to probe the mysteries of the cosmos, one question at a time. Among these enigmas, none has captivated our imagination quite like the sun, the celestial furnace at the heart of our solar system. For centuries, we've observed its fiery dance, mapping its storms, modeling its cycles, and capturing its fury through telescopes from a safe distance. We were led to believe we understood it, that we had mastered its secrets. But what if everything we thought we knew was only the surface of a deeper, stranger truth? This is not just another space mission. This is humanity sending a messenger to the very heart of fire, and what it saw changes everything. In this video, we unveil what NASA's Parker Solar Probe has confirmed, and why those final images may rewrite everything we know about our star. The Parker Solar Probe wasn't supposed to exist, not with today's technology, not with human limitations, but driven by a question first asked in the 1950s by physicist Eugene Parker. Could the sun be hurling invisible particles across the solar system? This mission became reality. Launched to dive closer to the sun than any human-made object before, the probe was a technological gamble, flying directly into regions where spacecraft simply weren't meant to survive. At its closest pass, the Parker probe came within just 5 solar diameters of the sun's surface, an unimaginably close distance by cosmic standards. As it accelerated under the sun's powerful gravity, it reached speeds no other spacecraft has ever achieved, 430,000 miles per hour. That's fast enough to cross the United States in just 20 seconds. But velocity wasn't the goal. Discovery was. And with every millisecond closer to the sun's corona, the Parker probe recorded data that would not only confirm Parker's theory of the solar wind, but expose something far more perplexing hidden in the sun's chaotic atmosphere. We've been taught to believe that the sun is a giant, predictable fusion reactor, that its surface is the hottest point, and its behavior can be traced with mathematical certainty. But the Parker probe proved otherwise. As it pierced the edge of the corona, the outer atmosphere visible only during a total solar eclipse, it encountered a reality that made no physical sense. The corona was millions of degrees hotter than the sun's surface, yet it was composed of a sparse, almost ghost-like gas. How could something so thin, so faint, be exponentially hotter than the roaring inferno below it? Traditional models of thermodynamics don't support this. It's as if some unseen force or mechanism is injecting energy into this ghostly layer of the sun, and doing it in ways we don't fully understand. Even worse, these heated particles are not just trapped near the sun. They escape, traveling vast distances and eventually colliding with Earth. The very phenomenon Parker theorized decades ago, the solar wind, wasn't just real, it was far more violent and erratic than we imagined. The Parker Solar Probe's mission was to solve this paradox. Its survival depended on a heat shield made from an unlikely hero, carbon. Not some exotic futuristic alloy, but carbon, a material with the highest known melting point on the periodic table. Yet even that wasn't enough. The shield had to be precisely angled at all times to protect the probe's delicate instruments from the sun's radiant energy, not just its temperature. What most people don't realize is that the danger isn't just heat, it's radiation, the type that can shred electronics, erase memory banks, and destroy years of data in a microsecond. The probe's carbon composite shield did more than block heat. It was a barrier against oblivion. Hidden behind it, the instruments measuring magnetic fields, particle flows, and energy signatures have now revealed something disturbing, fluctuations that no existing solar model can fully explain. Something's happening beneath the surface of the sun, and whatever it is, it's rewriting the rules of astrophysics. In one of its final close passes, Parker transmitted back images unlike anything NASA had expected. Not just streams of data, but snapshots of the corona in eerie, jagged shapes, twisting magnetic filaments, energy bursts with no known origin, and most chilling of all, structured patterns in the solar wind as if some intelligent force, was organizing the chaos. These were not the fluid, random motions of a purely natural system. Something about the order within the turbulence struck scientists as odd. It reminded them of algorithms, of self-regulating systems, of code. Could the sun, in its most extreme regions, be behaving like something alive? While NASA has not made any public declarations of artificiality, the silence surrounding the probe's most recent findings has only deepened the mystery. Add to that the fact that a memory card on board carries not just data, but a photo of Eugene Parker, and the names of over 1 million Earthlings. And suddenly the Parker probe feels less like a mission of science and more like a symbolic gesture. A message in a bottle, one we sent into the inferno to whisper back truths that our species may not yet be ready to hear. When the Parker solar probe entered the sun's corona, it wasn't just measuring temperatures or magnetic fields. It was decoding behavior. What the instruments found wasn't the expected randomness of solar emissions, but a rhythmic pulse, a fluctuating pattern in the way solar particles were accelerated and directed. This wasn't noise. It was structured. It repeated at intervals that defied chaotic models. More than that, the frequency of these waves seemed to vary in lockstep with the sun's magnetic field reversals and flare activity, hinting at an internal clockwork that remains completely invisible from Earth-based observation. This opened a floodgate of speculation among physicists and engineers alike. Could the corona be transmitting a kind of data? If so, to what end? Are these patterns ancient solar mechanics yet to be understood? Or do they point to a deeper, almost sentient process at work inside our star? For the first time, researchers began whispering about solar cognition, not metaphorically, but as a possible emergent property of plasma behavior at astronomical scale. As absurd as it sounds, the data from Parker forces minds to entertain impossible possibilities. For centuries, astronomers have tracked the sun's activity through its 11-year cycle of solar maximum and minimum, punctuated by flares, sunspots, and coronal mass ejections. These cycles were thought to be consistent, even if their internal drivers remained poorly understood. But Parker's data delivered a quiet shock, one that has not yet reached the general public. The sun's latest cycle appears to be intensifying prematurely. In other words, it's accelerating. The number of sunspots is increasing faster than expected. The solar flares are growing in unpredictability and violence, and the magnetic poles of the sun may be flipping earlier than ever recorded. This suggests a potential solar event that could eclipse anything seen in the modern satellite era, including the infamous Carrington event of 1859, a geomagnetic storm so powerful it set telegraph lines on fire. If such an event occurred today, it could knock out global communication, disable GPS networks, and fry power grids across continents. And yet, despite these risks, the information remains buried in scientific briefings and classified reports. Why isn't this front-page news? Perhaps because no one wants to admit just how vulnerable our civilization is to a star we thought we had under control. Among all the technology packed aboard the Parker Solar Probe, its instruments, its sensors, its hardened computer systems, there is one element that seems deeply human: a tiny memory card. On it, a photograph of Eugene Parker, the names of 1.1 million Earth citizens, and a PDF copy of a 1958 paper that no one believed at the time. But here's the strange part. This card is exposed, not to the point of destruction, but not entirely shielded either. Its purpose wasn't purely archival, it was symbolic, a message, maybe even a challenge. And yet, as Parker made its closest approach and endured the unfiltered rage of the sun's radiation, this memory card survived. Why? Engineers can point to tolerances and materials, but some believe this moment has greater weight. The fact that this digital scroll endured what should have vaporized it gives rise to questions that border on the mythic. Did we send something more than data into the sun? Did we receive something back? While this might sound poetic or even conspiratorial, several scientists on the mission team have noted anomalies in the card's condition, not damage, but subtle changes in electromagnetic alignment that they cannot fully explain. Is it possible the sun responded? There is an ancient fear that has always lived in our myths, the fear of being watched by the heavens. Civilizations have worshipped the sun not just for its warmth, but because it appeared to see all, judge all. We dismissed those myths as superstition, but what happens when scientific instruments return home with data that suggests something even stranger than those old stories? In one of the probe's last successful data bursts, a telemetry log revealed a sharp spike in particle directionality, as if for a moment the solar wind had redirected itself, not randomly, but purposefully. Multiple sensors confirmed this sudden convergence. For 48 seconds, the particle streams behaved as if targeting the probe itself. Then, just as suddenly, the pattern dissolved, replaced by normal solar turbulence. NASA's public explanation is non-committal, but privately, members of the Parker team refer to the event as the Eye, as if in that brief window the sun became aware of the visitor in its domain. And if that's true, if the sun can look back, then we may have crossed a threshold not just of science, but of cosmic awareness, a frontier where human curiosity meets something far older, far more powerful, and far less understood than we ever imagined. We sent a machine into fire armed with humanity's hopes, questions, and a 60-year-old theory once laughed at by the scientific establishment. The Parker Solar Probe didn't just survive the sun, it changed what we thought the sun was. Not a passive furnace of hydrogen, but a dynamic, unpredictable, and possibly intelligent system with secrets still unfolding. From impossible heat in the corona to pulses that resemble coated patterns, to a final image that suggests awareness rather than randomness. This was not the story we expected to tell. And maybe it isn't over, because Parker's journey has only just begun. It continues to orbit, diving closer with every pass, peeling back the layers of the universe's most ancient power source. But what happens when it gets even closer? What happens when we stop merely observing the sun and it begins responding? If the sun is not what we were told, then what else in the universe have we misunderstood? This isn't just science. This is a reckoning, and perhaps a warning. If you found this revelation as unsettling and fascinating as we did, make sure you subscribe for more cosmic secrets that the mainstream still isn't ready to talk about. And drop a comment below. Do you think the sun is just a star, or something far more conscious than we ever imagined?